Then I just wanted to, yeah. So when this comes, you will see a interface that is there, and it will by default throw up the screen, wherein you can choose whether you want to create a part, an assembly, or it's a drawing that you would like to create, and there are different things. So for the mechanical people, this may be familiar because you might have studied SolidWorks, but I think for the rest and the production person also would have definitely seen some CAD modeling in their engineering. But for the other branches, this might be a new kind of thing. So let me just take a second here. Just give me a second. Mm. So you will see this window of SolidWorks. Once again, I just wanted to give you guys again a quick intro. So SolidWorks will keep showing you these fancy parts and products that were designed in their software. It's a nice. Every time it will keep changing if you log in the splash screen. Hold on. Yeah. So now, by the default, the basic thing in SolidWorks that you can do is you can actually create something called a part, and then you make, and that's you can click there and you can start that. So for those of you who have installed the software, when you started the software, it would have asked you for the unit system of the system. That's a very important thing. And if you did not set it that time, or you set a wrong one, you can always go and change it here at the bottom of the thing. It's gram second, millimeter gram second. You can also edit this and then create a millimeter kg second. There is a meter kilogram second, which is the SI system, but this you cannot use because in regular practical design, the dimensions that is used is millimeters and not meters. And of course, this is by default available millimeter gram second, but I know kgs would be a better unit. You can always create custom units if you want, but otherwise make sure that you're at least working with this millimeter gram second units, because this is very, very important. And if you get this wrong, you will be creating parts in inch system or centimeter system or meter, and you will not know, and you will have to redo your entire work. Okay, so this is one very important thing when you start with SolidWorks. Make sure you are in the millimeter gram second. Okay, so SolidWorks, when you open, this is the space where it's like a space where the virtual world where there is nothing that is yet been created, and by default, SolidWorks will give you by default no material is specified, and you can see there will be three default planes, which is the front plane, the top plane, and the right plane. So the basic workflow of SolidWorks will always start with a plane. The plane can be one of these default planes that is given in the software, or you can actually create your own reference planes, which is like with from this. But for starting, I think we will work with since you already seen other CAD tools like Alias and Fusion and things like that. This will also be familiar to you because you would have seen all these kind of systems. It's basically geometry that's going on here, and nothing that is new. So basically, to start a SolidWorks model, solid model, you basically have to start from a sketch. So you will select a plane, and you'll select a plane, and then you will say the top plane, and then you say I want to make a sketch on that plane. As you can see, that this top part of this software is called the ribbon, and this is called the feature tree, and this is the model space. Okay, so you have very important things. You'll be interacting with these three spaces for getting commands, and when you do something, it will come here. So that is the thing. So when you take the top plane and say start sketch, you can, it will sort of, the space will rotate, and it will, yeah, I just wanted to confirm if I'm audible, Kumari?
Yes, sir, audible.
Audible, okay,
Yes.
because, yeah. Okay, so this is you'll see the top plane. And once you come, as you saw, the space rotated and you're looking perpendicular to the plane now. So if I hold the mouse middle button and you rotate, you'll actually see that the middle button is the rotate button in SolidWorks. And to zoom, you can use a scroll wheel, or you can press Shift and then middle button. Shift, middle button, or or the scroll wheel for zoom. And it's Control for pan. Control middle button is for pan. Okay. And then there is depending on where you are, you will have this. If you right click, You will see this context, right click and drag, you'll start seeing these context menus. It's not important for now. When you start becoming a more advanced user, if at all you become an advanced user in this thing, you can start using these. Otherwise, it's not required. So as you can see, it is, I actually, now I'm not looking parallel to the plane, but to draw a sketch, you should always be looking perpendicular to the plane. So I will start, and I can say, and as you can see, when I created this, hit the space bar, I'll get this view, and to look at it from, look at the model space from which particular plane you want to look. But for in this case, I want to look normal to the plane, so I'll click this particular thing and I'll come back to that space. Okay. So now, since most of you are from an engineering background, you would have definitely done some CAD work. If it is not 3D modeling, at least you would have drawn, so you would have done some AutoCAD or and things like that. So you will be familiar with these geometrical things like drawing a line and things like that. So typically, I would start a thing by creating some reference lines, say like a center line. Okay, and just create the center line. Hold on a second. Yeah, center line. Yeah. So and then I'm going to create something called a sketch, which I assume that I want to make a block of steel piece, which is like a square thing. So I'll create this, and then what I will do is I have created a rough shape of the block of metal that I want to make, and then I have to dimension it. I'm going to say this is going to be 100 or I say 150 wide. Okay, this is why I said the units are important, because you have to tell it in mm, because no other system is going to work unless you are in the US, designing the US or UK, where in case you'll be using the inch system. But in the Indian and rest of the world, it's going to be millimeters. Okay, and then now you come here and say this is some 60 millimeters. And you can then you can see one more thing about the sketch is that you can see the blue color and the black color. The blue color means that it is not constrained yet. That means it can still move around. As you can see, it can move if you drag it. But if something is black, it means that it cannot be moved around. It means it's been completely defined in the space. And if something is blue, you can actually, so this line's ends are not defined. That's why you can extend the line. But as far as this perpendicular straight line is concerned, it is always going to be vertical, and it's going to pass to the origin. That's why it is completely, and this horizontal line is always going to be horizontal and pass to the origin, which is enough to define the line. Two conditions are different. So everything is from, whatever you have seen from geometry, from your school, and all these things will start, is exactly what is happening here, or engineering graphics, if you have studied that. And yeah, so that's the thing. So, and then now I wanted to do, and since these things are, I'll add some more dimensions. Like say, for example, I'll say this is 75. The moment I do that, these two lines will get fixed in space correctly. And then if I add one more dimension, just basically this to the center line, and say it is 30 millimeters to make it center, it is going to become a central, central thing. So now I'm done with sketching. So I go to the right corner here and say exit sketch. So you'll get used to this pretty soon. And I'm just giving you a quick intro, and you're not expected to grasp everything if you're not seen SolidWorks before. So it's perfectly okay. Just see what I'm talking, and then I'll tell you how you can pick up these skills if you need to do that. Okay, now you exited the sketch. So now the sketch is nothing but a square thing, and then you come up with and I'm holding the middle mouse and I'm showing you it's rotating in space, and basically I sketched on the top plane. If I go normal to it, you can actually see the sketch. So once I'm finished with the sketch, there are multiple things you can do with it, which is basically called the features. Okay, so you can actually extrude it, revolve it, sweep, loft, there are different things. We'll go one by one. The first one I'm going to do is basically extrude. So I can take this thing and then tell extrude, as you can see, right? So I am going to, I'm just going to start the command again. I'm going to select the sketch, and then I'll say extrude. Okay, so now you can see there is a different, how much thickness do you want? Is it now by default it will put 10. Do you want 24, 36, 24? You can actually drag this and then adjust it, but this is not a good way to do it. It's very rarely, I hardly people use these things. But of course, if you want to just have a rough idea of what things are and think, you can do that. But generally, what you do end up doing is you enter a dimension explicitly here. Say it's a 12 thick plate that you are going to do. Okay, now you've done this particular thing. So now let's say you want to cut a hole in this again. And I'm sure these are, you would, any fusion was done, the same things would have come. I just wanted to tell you one more thing. Now, when you look at this thing, since you're all designers, you have been doing product visualization, sketching, and things like that, you know that the lines don't, which are going far away won't diverge. It will actually converge. And this is a bit disturbing if you are from, from the design background to see these lines diverging. So what happens, what to do, how to fix that is basically you go to your, in the top, if you go here, this will pop out. And then you go to view, and then you go to display, and then you say perspective on. And that happens, it corrects. And now now it look more natural and how you expect to see a, a cuboid or a flat plate. So now I'm done with creating a part. I'm just going to say, save this part. So I'm going to create a new folder. This is going to be, I don't know, I think I'm just going to give a project name, project. So this is one more thing. You need to save all the files in one particular folder for AutoCAD. Now this is actually going to become quickly redundant because the 3D online thing is going to come and everything will be sitting in the cloud like a OneDrive or this other thing which is called the what do you call Google Drive and things like that. So I'm just going to create this thing called part plate. This is a plate. Okay, and I'm going to say save. Yeah, so now I've created a plate. Now I want to add some more features to it. I can show you some more things, like for example, let's say I want to cut a hole in the middle of it, or I want to cut something, a hole. So how do I do that? I can say, again, go to sketch, and I'll say sketch, and I'll sketch this time. I don't use any of those reference geometries of the just by default imaginary geometries, but I will pick the surface of the plate itself that I just created. So I can either use imaginary reference geometries which are only there in it's not real. It's like imaginary references, or the real ones like these. Okay, so I'm going to take this surface of this plate itself. Now that you can see, the origin has again come, and that's the plate. So now, ideally, to sketch, I need to look perpendicular. So again, I'll hit the space bar, and then I'll pick this command, and it will come here, right? And then I can take sketch, and I want to cut a hole here. So I'm just going to put a circle. And then I'm going to say that it's going to be centered at the origin, and it's going to be like this. And I take a smart dimension, and I'm going to say this is about 22 millimeters, in diameter, right? And then I'm going to say, okay, it's done, and exit sketch. So now when I come back to features, I will tell this thing. In this case, I can create it like a extrude, and I can use this feature to create extra material, right? Like this, like a pin. Or I could have, I'm going to delete this feature, and I will get this sketch back, and then I'll say cut extrude, right? So cut extrude will cut through the material and will create the other thing. So you can just let it go. It's basically cutting 37 millimeters. I don't know why it took that, but it will come by default. You can tell I want to cut 10 millimeters, right? So in that case, it'll stop inside the material. It won't cut. It won't cut through the material, right? Then I can actually, or I can edit this feature and say I want to cut 13 millimeters. In that case, it will cut through the material and come out on the other side again and create a hole. Then there is other way to define this cut, which is basically you're going to tell cut up to a surface. Instead of telling 13 millimeters, you can tell cut till the surface. Okay. So the advantage of doing this is that even if you decide to change thickness of the plate, it will always cut and create a hole. So this is the advantage of SolidWorks, is that if you capture all this intent, right? Even if you edit now, I will go back and tell this, instead of 12 millimeters, I'm going to make this 15 millimeters thick. Okay. Still, the part will rebuild and there will be a hole. Instead of that, if you had defined this as instead of up to surface, if you had done it as a blind hole, which is up to 12 millimeters, which is the previous thickness of the plate, what will happen is that when the thickness of the plate changes to 15 the hole won't come again. So you'll have to go and edit the second feature. But instead of it, if you are told cut till the surface, it will automatically update and do what is necessary to get it up to surface and here and then done. Okay, so this is one part. So how SolidWorks works is you basically start creating parts, and the part is typically what you would expect in a real physical world also. Let me just go here. Yeah, so typically what you expect in a physical world as well. Yeah, so yeah, perspective. Yeah, so you have a part, and then you have you'll. So now typically a product that you would make would have parts from different different parts. So then again, so how you go about in the SolidWorks is you create different parts. I'll create a second part, which is basically going to be a peg that goes into this hole. And this is a typical toy problem that is done. So I'll just create this new part. And I'll also use this opportunity to show you other features and things like that in the thing. So this time again, I come to a new part, which is like, it's saying part 2. It's not named yet. So in this case, I'm going to take the front plane, and I say I want to sketch on the front plane. Yeah, and again, you'll get this front plane, and you get the origin. And it's always a good idea to put in a center line or some reference geometry like that to start your process. And then so one more thing I just wanted to show you is that when you start drawing the line, SolidWorks will keep allowing the command to go. Okay, you can click and go. And if you want to stop drawing a line, you can hit the escape key, right? So that's how you do that. So I'm going to delete this. Just these are all small things that you would come to use later. And now I'm going to sketch a line. I'm going to draw something like this because I want to put a peg in this. Yeah, I'm going to draw the line from here to here. And I'm going to move this here. I'm going to move this here. Yeah. So now these two lines are defined. Now we need to define this distance. I'm going to just put something here now. I'll just leave it there to whatever it is the default because I have forgotten what does the diameter of the hole I had created in the previous thing. So now if I go to window here, I can actually switch to the plate drawing. And then I can go here. This feature sketch markup. Markup is a new thing that has come up, I think, in the last couple of editions, wherein you can actually, say make this hole bigger. You can do all those kind of things, but we will leave it for now. I'll just go to evaluate, and I'm going to use this tool called measure, and I'm going to measure this thing. And I had put diameter of 22 millimeters, right? So now I will go again to window, or there's also you can hit the escape key and then go to window and switch to back to the other part I was doing. This was 22 millimeters. Half of that is 11, and then this thing should be 20. Usually you would pick some round numbers. Nobody makes a pin that is 20.88. Okay, so that's done. So now there's only one blue line, which is basically we need to fix this distance from the origin. So basically I can go back to the sketch, smart dimension, and say the thickness of this head is about 14 millimeters, right? So this is done. So now I have a section. So now what I can do, I can extrude it, right? I can go to the features and again say extrude and then create something like this, right? But this is not the part that is going to go into the hole. So this is not what we want. So I'm going to just say Control Z. It works in SolidWorks also. And instead of it, I'm going to take something called a revolve, and I'm going to take this section. and you can see it's by default picking up this line as the axis of rotation and rotating and creating a geometry, which is basically something that looks like a nut. Now I'm done, and I'm going to say file save. It's called the pin. Okay, so now you're done. Now if you go to your folder in Windows and actually see this particular folder, I think it's on the desktop. Yeah, SolidWorks intro. If I go here, I'm working in this folder called project. You'll see two files, the pin and the plate, which you both created. So these are the part files. And if you actually look at the extension, we go to view. How do file name extensions? You can actually see it's an SLD part, SolidWorks part. That's what it means, right? Yeah, so it's basically a part file. And if you extension, and you can actually look at here in the type also SolidWorks part document. So your project folder will start having these part files and coming, and when the online thing comes, this will not be relevant. But I'm just saying that if you're working. Yeah, this is done. So now I go back to the window and go back to the pin. So this is done. So now I have two parts. Now I want to create an assembly of two parts. So what I do in that case is I go and I create something called the I go to new, and here instead of part, I'm going to pick something called the assembly, right? Assembly, and say okay. So when I create the assembly, SolidWorks does a little bit of smart things. It will already start listing the open parts in your thing. Even if it is not there, you can go and say browse and go find the part in the folder system and bring it in. So first thing that I want to bring into the assembly is this plate, right? So now, as you can see, the moment I click that, this has appeared here. I can just leave it here in the assembly space. It has gone and sat somewhere because it's the first plate. It is not, it will go and sit by default, and it doesn't matter where it goes. So now I'm going to create something called, again, the view, which is not in perspective. Usually disturbs me, but it may not disturb you. So I'll just create that thing. Okay. And one more thing I want you to note is that you can see this hat image here. This is basically coming because you're using SolidWorks educational version. Okay. So the problem with this, I think, is that whatever you create in this cannot go into commercial, this thing, or there's something like that. But I just want you to note that this hat means that it is created in an educational version. So basically, they don't want you to use your software that is insured for educational version and then go start and create some commercial work and give it to for commercial these things. And one more thing I just wanted to tell you while I was saying that Kumari had shared with you the license files. So that is restricted for the class. So that license key, please do not circulate to the wider, in general, or put it on the internet or with your friends or anything. This is meant for the CAD class. If anybody else wants to use it, you can reach out to Kumari or Professor Gurumoorthy and then take permission to get the thing. Yeah, but anybody in the class are free to use. So you can install it on your computer, and if you want to install it in more than one computer also, it's okay. Please go ahead, but try to keep the key secure because it's a paid license. Yeah. So now you have this assembly file. As you can see, it says asm01, which is the default name for assembly, and now I have only one part in it, and now I want to bring in another part into the assembly. So I go to the assembly and I would say insert components. It's pretty natural, most of the commands, and then I would say bring it in, and I keep it here, right? So I'm having a doubt whether these things match. Let me just check that. Evaluate, measure, and I'm going to check the diameter of this is about 22 millimeters, and then measure diameter of this is also millimeters. Great, it matches. So now I want this pin to go into this hole, right? So there's some in the assembly function, there is something called mate. After inserting components, you do something called a mate, right? And the mate is basically you start giving geometric conditions, which is basically I'm going to say that this part, this circular face, and this whole circular face are going to be concentric. And since SolidWorks has some intelligence, it will automatically understand that when you select two circular faces, it means that you're trying to make it concentric and this thing. So clearly, SolidWorks is not smart enough to understand that you actually wanted to go the other way, but at least it understood the concentricity bit. So now you come here and there's an mate alignment option. By default, it had flipped it the other way. You flip it the other way, it will come here. Now its alignment is correct. Yeah, and I'm going to say this. So now this part will not move around anywhere in this thing, but it will always be concentric. So I can actually move it here and bring it. Now I dragged it and brought it here. But as you can see, this part is still able to go up and down through the hole, and that is not something that you want. And you want this head to obviously touch this face. So again, since the mate command is open, I'm going to just go here and take this face, and this face. And by default, SolidWorks assume that you're trying to make it coincident. It's one of the mates. There are other types of mates like parallel, perpendicular, what is this? Lock two components together, distance, angle, and depending on the context, you can do different things. Yeah, so this is a concentric mate, and I'm going to say yes. So now what has happened is you have a SolidWorks assembly which is basically sitting inside the this thing. Okay, so now we are done with the assembly. You'll have to save your assembly file. It's basically when you say save all, and you will go here and tell it's going to be plate and pin assembly. It's going to go into the same project folder. Yeah. So if you go to the folder structure again, you'll actually see a third file that has come in. It's called a SolidWorks assembly document. So what you should know is that the SolidWorks assembly document does not have these parts information in it. It is basically dependent on these other parts to create this thing. So if you go ahead and delete any of these files from the folder, what will happen is that when you go back to your assembly, yeah, it'll throw up an error. Okay, so be careful to hold all the files together. So this is basically the type of process that you follow to create parts and assemblies in SolidWorks. So there is Is there anything that you want to ask at this point of time, or I can just continue with some more introductions? Anybody has any doubts? Hello?
No, sir.
No, okay. All right, so I'll just continue with this thing. So now there's another important thing in these are all what is called mechanical CAD type of applications. So let me just go and do something. So then if you go to SolidWorks, there's another thing called drawings. All of you are familiar with drawings because you have an engineering background. So let me just show you that process as well of how to create drawings. So it's asking you the sheet format. I am going to take an A3 sheet. It's an ISO A3 sheet. And there are other standards also you can browse. It's not just ISO, you can use depending on you create your own custom standards and things like that. So I'm going to create it's an A3 sheet, right? So I want to bring in the plate drawing into this. Okay. Yeah, and I want to bring in some view I want to bring in. This is one view of the plate, which is the side view, and I can create another view. Okay. If I want, I can create perpendicular views. I can create this view. I can, all those things. I can do this kind of. It's not required, but we can do it. Okay. Yeah, different views. Yeah. And I can actually introduce a model view also if I want, and I get to the plate. And these days, it's normal to see the. Not the model view. I want. Wait a second. I wanted a section. Yeah, section views also I can show you that. Okay. So basically, once you bring it here, you can actually come back here and you can, dimension the drawing, all these things. Sorry, you should not use sketch dimensioning. It's the wrong thing. You can do annotate dimensioning. Until this is 150, until this is 50, and this whole is going to be 75 millimeters from this edge, and it is going to be at a distance of 30 millimeters from this edge, and the one other important dimension is the thickness of the plate. So I'm going to say that this is going to be the plate is a 15 plate and things like that. Okay. So you can create the drawing and a hit save button, and it's asking you where to save it, and ideally you should save it in the same folder as a, and the file name will automatically be the file name of the part that you create. Okay. So now if you go to your thing, you will actually start seeing a SolidWorks drawing document as well. So you have a plate SolidWorks part and a plate SolidWorks drawing. So now this is a drawing, and obviously drawings are much more complicated, as you know from this thing. This is just a toy problem to just get these things going. Then I wanted to get a, so you can actually create, you can leave a 3D drawing if you want of the part. These days, this is becoming a convention of leaving a 3D drawing around in this thing. So, and also if you see, this is becoming very big. So if you want, you can adjust the scale. Where is the scale? Use custom scale. Instead of 1:1, I'm going to say scale is usually drawing size by actual size. I want the actual size to be in drawing size should be half of the actual size, right? Oops, what happened? No, 1:2. Yeah, so it just becomes a small thing. So it's there here. So similarly, if you want, you can actually create scales and all these kind of things from your engineering drawing. You must be familiar with all these things. So basically, this is the workflow of SolidWorks. You basically create parts, which is and then you create an assembly, and then you create drawings that go for manufacturing. And if it's a 3D printing or something like that, then the 3D file itself goes to this thing. And the drawings can be created for parts or assemblies. So let me create a new drawing. And suppose you wanted to create an assembly drawing, you can do that as well. I'm going to take this and then keep it here. As you can see, it has come here. No, I want that. Okay, this is one more issue was there. This is a projection issue. It's projecting in third angle. I think you guys know all those things about projections and things like that. If not, it's you can actually change the projections if you want to. So yeah, so I'm going to change the drawing size to actual size. Drawing size will be half. Okay, yeah. So you can. All right, so you have your drawing and all those things going. Next is going to be, yeah, of course, after everything you have to save, and it asks you something, and you say yes to it, and then let's see. Okay, so if you go here, you'll again see another file that has come in. Is the plate pin. Again, it's a SolidWorks drawing document. So whether the drawing is created from a part or an assembly, the SolidWorks document type is going to be. And this one you can print it out, you can make PDFs of it and all those kind of things for manufacturing release and things like that. Of course, dimensioning and all these things have to be done to get to this thing. So this is a typical workflow for creating, thorough mechanical type of assemblies or details and things like that, which is where you start with SolidWorks itself and you create everything on your own. But say, suppose you're making something like a mouse or something like something which is more like a free-form thing, which has got a curves and things like that. Then what happens is that you'll have to actually. So I'm done with this particular thing. Is there anything that you would like to ask me at this stage of point of time, or I can continue? Anyone has any doubts? Am I audible? I'm just trying to read. Hello?
Yes, you are audible.
Yeah, no, I'm just asking if you have any doubts, I can continue.
So far, no doubts from me. Sorry.
Okay, sure. Yeah, if you have any, it need not be anything specific to this, but if you have generally been thinking on all those things also, you can ask me.
Actually, I
Yeah,
have one thing.
yeah, sure, go ahead.
Recently, I came across this 3D experience platform from the Dassault Systems.
Yes.
What is it? Is it something similar to Fusion 360 or
Yeah,
something?
so it's basically SolidWorks competition to Fusion 360. But what is the good thing about 3D experience is that whatever you saw right now will happen like like a Fusion 360. And so many of the things like I was telling, the folder file structure and all those things will be taken care of. It will be on the cloud and things like that. Yeah. So it's essentially a SolidWorks reply to Fusion 360 and more. So yeah, but the problem, the comparison is slightly off because Fusion uses a slightly different type of you know method of the way it is the geometry is structured. In SolidWorks, what you can see is it's very clear. Everything is apart, and these are the feature tree and things like that. Right, so Fusion is slightly different, and Fusion is a new paradigm. So I don't know where it is coming, where it is going to go, when is it going to come. See, Fusion is very easy to learn, but I don't know where, considering the industrial use of it, I don't know when it is going to. It's very popular in the maker space, hacking space. People are trying to make something, they want to quickly do something. It is a good thing to go with, but I don't know about the other things. Well, this thing about I'll come back to these things. Yeah, so yeah, basically 3D experience is going to be the way forward, but maybe it might take already it is there. So let's see how you can use that and things like that. I am checking whether the IISc license has got the 3D experience access. If yes, then you can do it. Otherwise, we'll see how to get to access. We'll request the professor to look into it. Okay. Yeah. So this is done. Uh, yeah, so now I wanted to tell you one more thing. This is for creating all these mechanical kind of parts. But say, suppose you wanted to create something like a mouse or hold on a second. Record. Yeah, I come back to SolidWorks. So suppose you want to create something like a mouse or something like that. So what happens in that case is that it's a freeform surface, right? So you can do it in two ways. So the real ways you can model everything. So there is a way of doing everything in SolidWorks, which is not the way the industry kind of works. Because what happens is that the SolidWorks is very limited when it comes to modeling freeform surfaces, and it will be tools like Alias or what is it called? Rhino that will be used for creating, or iSemSurf that will be used for creating your freeform surfaces, or you can to some extent create it in Fusion also if you want. Okay, so you will actually create that surface in softwares like Alias or Fusion or Rhino, and then you will actually bring it into SolidWorks and then continue with the workflow, wherein SolidWorks will bring the part to life such that it can be sent for manufacturing and things like that. So I'll try to quickly show you how to do a freeform part. So for this example, I'll be creating everything in SolidWorks, but actually speaking, in the real world, you would not be doing this, but just for the sake of example, I'm going to do this. So let's say I'm going to take the front plane and I'm going to sketch and sketch. Okay, I'm going to take the spline tool. As you can see, the only tool that is there for freeform thing is one thing called spline, and there's not much you can do with this. But then if you see Alias, you have the splines of different kind with control points. You can adjust the weights. You can control its tangential continuity, geometric continuity, curvature continuity. So none of those kind of things can be done easily in SolidWorks. Okay, so now I'm going to just say the mouse is going to be, oh my god, I put the point too close and I'm going to not going to get the form. Yeah, so I'm just going to hit escape. So I got say the side view top contour of the mouse or something like that I can say, and then I need to create another geometry which is here, right? So for that I'm going to do something called I'm going to insert a feature, but this time I'm going to create a reference geometry. The reference geometry I want is no, I need to exit the sketch. I'm done with the sketch. And of course, now with just one curve, you can actually go to SolidWorks, insert surface, and say extrude, and pick this. You will create horizontal surfaces, right? And if I add a direction too, I can do a horizontal surface. So you can create these one, not doubly curved, but singly curved kind of thing. So this is not what we want, but I'm just trying to create this. This SolidWorks is very limited when it comes to drawing freeform. So you should not be doing this in SolidWorks. You should be doing this in Alias or in Rhino, and then bringing in the surface here. So, but just for the sake of example, I'm doing this, and I'm going to take a plane, and I want to create this plane which is parallel to the top plane, but it's passing through this point, right? So the second reference is going to be this point. So I created these two things, the plane will be created. So as you can see, the feature tree, the new plane has come in. Okay, so now I want to sketch something, and I will sketch on this plane which I have selected and say sketch. And sorry, I take this plane and they say sketch. So now obviously I'm not looking perpendicular to the sketch. Again, I'll hit spacebar and I'll say I want to look perpendicular to it, and I am going to draw again here, sketch, and I'm going to say okay. I'm going to just say I want to create again another spline, and I'm going to, it's a little tough. Nearly as you look into the three views, and you will be able to do it. And I'm going to start from here, and then I'm going to look at it perpendicular as much as possible. Create here, create here, create here, and then say escape. And then I will need one more thing. I need a line, which is here. When I come vertically, yeah, and I'll say escape, and I'm going to mirror this line or about this line. So I'll take this component and I'll say mirror, right? I want to mirror only this spline. I'm going to delete it, and I'm going to mirror about this. Okay, now we got a sketch, and I'm done with this. And then I'm going to say, I go back to here, part, insert, surface, and I'm going to say I want to sweep. Okay, I want to sweep this profile, and no, you have to tell which is the profile and which is the section. We can do both. So the profile is this one, right? And that's correct. It's automatically selected because of some built-in intelligence the software has. And then I want to say the path. The path is around this thing. So now you got a shape which maybe looks like the top of the mouse or something like that. Obviously, it is nothing like that. So now this is done. And you can actually see there's a clear joint line here. And if you can actually, you will not see it, but we don't know the curvature continuity. You can actually evaluate the surface and all those things just like how you would do in, okay, somehow it seemed to be continuous surface. Great. The continuity has come. I don't know how. No, it is not. As you can see, there's a clear line here. So this is what you do in Alias. And what happens is that if you have a line, the reflection will go. Imagine a car bonnet having a line where you don't want. That's where the curvature continuity and things like that comes in, and you have to fix this. Right? So you can do it in SolidWorks also, but this is not the best tool to do. But I will just, for the heck of sake of demo, I will do it here. Okay. Let me go to sketch one and say edit the sketch, and let me see if I can get a curvature continuity going. And select these two curves, and I will tell there is a G3 continuity, and I don't know if it's got adjusted. Let's see. I'm not too hopeful. Let's see. Yeah, now the line has disappeared because you got the curve, you G3 continuity going to the that curve. So now you got a surface. This is typically not the software to do a surface, and you would actually do this in Alias, and then you would import this surface into Alias. So assume that till now you did all this in Alias or Rhino and things like that, and you got the surface into SolidWorks. But once it comes into SolidWorks, the surface can be brought into real geometry. A real geometry, just imagine this is a plastic part and it's made of some, say, 2 mm thick plastic molding. So you have commands in SolidWorks like you come over here and then you say feature This feature, just hold on a second. Take this surface feature. See, if you go to boss and then you say something called thicken. Okay, so thicken command will actually tell you want to thicken to the bottom, thicken to the side, you know. So to understand, you can tell I want to thicken to the bottom, because usually what happens in product design work is you would have created the external surface in Alias, done some renderings to know how it looks and all those things. So you'll thicken it to the bottom. Just for the extreme case, I'm doing it, or you can do it to both sides if you want, or you can do it only to the top, depending on what the part you're making. So typically it will be to the bottom with the plastic part, since you have the exterior surface. And just to show you the thickening surface, I'll make it elaborate, make it a 10 mm thick surface. No mouse cover will have such a big thick thing. It'll usually be say 1 or 2 millimeter. So let me just put for say some 1.5. You will not see it, so the heck, so for the sake of demo, I will make it 2. Okay. So now you have a thickened part. Now you can actually create something else, cut it, then you'll then say save. I'm going to say stop cover. Yeah. So mouse top cover. So you'll have to do a lot of work before this actually becomes a real mouse cover that can go to 3D printing, or it can actually go to say the next people in the workflow, which is basically the tool and die makers. They will take this model and they'll use SolidWorks itself or some tool like Proe to make the plastic injection molding tool of this. So also once you have it here, SolidWorks also has some very advanced features. Like say if you want to put in some fastening features, like say you want to create a mounting boss, and you want the mounting boss to be here, and this you can adjust all these dimensions and play around, and say yes, and then you can have another mounting boss here, which is here, and then you say put it here, and yeah, done. Right. So you can see this. I'm going to change the display with the edges. It's more easier. Yeah. So you can see these. Yeah. So I can see this could have been something, and you can create these parts of this kind in SolidWorks. So these are the two major workflows in SolidWorks, which is basically creating traditional mechanical parts like what you would see, like this, or be it an engine part or a motorcycle part or whatever it can be, or it can be these kind of plastic molded parts for this thing. So these are the two, major workflows that you can do in SolidWorks. And SolidWorks also claims that it can do other things, like for example, they say they can do simulation if required. But this is all very rudimentary. For simulation, just like surface modeling, you have to go to areas. For doing simulation, you really need to go to ANSYS or some other tool like that. And SolidWorks also says that you can do CAM. But again, depending on the manufacturing people, they might be using some other software like Mastercam or I don't know, Spirit or something like that. So SolidWorks core capability is in making 3D mechanical models, and it needs a host of other tools. So as a designer, you need to work with different tools before SolidWorks and after SolidWorks to get your thing going. Now there is this new paradigm coming, which is basically trying to create hybrid tools that gives designers everything they need, which is what Fusion is trying to some extent. Is basically it gives you ability to do surface models, it gives you the ability to do subdivision based modeling, it gives you ability to make 3D models, and they'll say that you can do 3D printing, you can do CAM, you can do renderings and everything. Yeah, that's one more thing which I wanted to mention, that there is also other tools for rendering, which is usually like tools like HyperWorks and things like that, or V-Ray. SolidWorks also has got a rendering tool if you want, but then those are all not the tools that you would come to SolidWorks for. SolidWorks is basically for making the geometric files and sending them off to manufacturing, and also making some renderings when you need them. Yeah. So this is pretty much what I had to tell you. The two basic workflows for creating from surface to part, and also creating the part from scratch in SolidWorks itself when it is there. So these are the two. So anything and yeah. So the 3D experience part, I don't think is very different. You can actually create there also if you want all these things. It's not an issue. Okay. Anything else that you would like me to discuss, or if you have any doubts, I can talk. Otherwise, this is pretty much what I wanted to show you guys today.
I wanted to ask, like, if you want to build on that mouse cover that you made,
Yes.
entire form within that, like you made a surface, but then if you want to build an entire solid, is that possible with the same?
Yeah, yes, you can actually build. So let me tell you the workflow. See, this is not how it works. So since you asked this question, I'll just go ahead and show you that also. See, now when this is not how it's going to be done in SolidWorks, right? So what usually happens in SolidWorks is that you will actually create. Okay, say let me just go to here and I'll go here. I'll create a part. Um, I'll say sketch and I'll say sketch and then I would say okay, and I'm going to I'm not going to make a doubly curved surface now because I need time for modeling that, but just for the asking you to answer your question what you mentioned. So let's see, we're going to make a very okay, let me okay, this is fine, I think. Yeah. This is the surface. Now I'm going to say features, I'm going to say extrude, and I'm going to do it to direction 2 also, and I'm just going to eyeball it here because it doesn't matter. No, I think I'll make this 45. No, 45 mm is too big, but yeah, it's okay. And 45 mm. Okay, so typically what happens is that, so now I'm just going to do some more. So there are other tools, other things in SolidWorks, like for example, you can do a feature which is basically something called a fillet. If you want, you can fillet. I don't know whether this is going to fillet here because of the strange edge that it has got. It's not showing a demo, so I doubt it will build. Yeah. Okay, so this is the, and I want to add one more edge to it, the feature. So this is not how mouse look in the modern era. But if you look at very old mouse, it will look like this because of the reason that this may be created in some, tool like this. So let's say this is your mouse. Okay, I'm just going to save this part here. Okay, call the mouse geometry. Right. So now this, what you're seeing here, this particular geometry will come from, say, a tool like Alias, or it would become from Rhino, and it would be very fancy, like how you guys wanted it to do, the doubly curved. It'll have nice features, it'll flow, or all those kind of things. It'll be done, and that model will be bought into SolidWorks at this stage. So assume that this was a very the geometry and everything is like what you like, the Dell mouse you have or the HP mouse you have, and it was created in something like Alias or Rhino. So you'll import this geometry here, right? So then what you'll do is now, okay, there is different workflows. One simple way of it is, now I can go here and I'm going to say, since I saved it as mouse geometry, I am going to close this file, and then I'm going to close this here. I'm just giving you an example of working, how you could work. And then you could go to this intro folder and go to the project folder, and then you take the mouse geometry, copy, okay, and paste, and paste again. This is one way of doing it. There are other ways of doing it also. I'm just going to show you. Okay, I'm just going to close this again. Don't save. I'm going to name this bottom. Imagine this is the geometry which I've imported from from something like alias. Okay, and I will create bottom and top. And I'm going to just minimize the screen, and then I have closed SolidWorks. Is it? That is fine. All right. And then I'm going to open this thing called the top. Please bear with me. I may close the software and it is, yeah. Yeah. It is giving you, see, as you saw when I opened it first time, there was nothing, but now as you keep using it, things will populate and you can go, this is like any Word or any other software. Okay, so now I'm going to get into this space, and then this is I call this mouse geometry top. Okay, so this, imagine this is the full thickness of the mouse. Usually what happens with mouse is that it will have a joint somewhere here. So I am going to insert reference geometry. I'm going to insert a plane, which is from this. I'm going to switch the direction. Hold on. Flip offset. Yeah, I'll bring it there, and that which is about 5 mm from the bottom. Okay, so this is the plane. So this is the plane, and I'm going to insert. I'm going to do something called a surface cut. Cut, yeah. It's called with surface, and plane is also a special case of a surface. So I'll take the surface and I'll tell this. Oh, so I've cut the wrong direction because I want the top. So I will go here and edit this feature, and I'm going to flip the direction of cut, and I'm going to knock off the bottom. Okay. So now you can see this. It has come here. So now this is the top of the mouse. So now I will take this feature, this entire geometry which has been there, and then I'll go to again go to insert. And there's a feature called shell where I'm going to go here, and I want to check this. No, I want to take the geometry. I want to take the body. So to select the entire body, if you go to the feature tree, there's a solid body. Depending on how you model, you might end up with multiple bodies, or just, usually it's good to keep the entire body as one, but it can end up having multiple bodies. Yeah, so you did a shell. Oh, I forgot to show you some features in the shell. The shell thickness is 10 mm, is too much. The mouse wall was 2 mm as we had worked before. So we keep that as 2 and close it. And then, right. See, now it is actually shelled, but you are not able to see it because the bottom surface is still there. To show you that, I'll actually take a section view. As you can see, it's there. So inside is hollow, but that's not how a mouse cover is. The mouse cover won't have a bottom. So you'll have to go to the edit the shell again, and you will tell that you will select the faces you want to skip. So you will select this face, and you'll tell, okay. So now it's done. And now I disable the section view. As you can see, now the bottom has been hollowed out. So now you will create this, right? And then create the save part. All right. And maybe I will just show you something here. You will go here and say insert something like a fastening feature, like a mounting boss of where the screw will go in. You will keep one here and say okay. You will repeat the command again. Insert fastening feature, take a mounting boss again, keep it here, and then say yes. Right? So this is done. So now the mouse top is done, for example. I'm just doing this very quickly because you need a lot of time to actually get all this aligned by defining reference geometries and getting your direction right and all those kind of things, right? That's done. Now I'll go file and open the folder called, from this folder, I'll open the other folder which I called the mouse bottom, right? Yeah, so this is again the same first geometry that I had used. So you can actually, so this is a hack way of doing wherein you create two folders into. There is other ways of, in SolidWorks, like if you go a little, there's something called a split line. You can actually use the same geometry, create a split line, and then come back to it and all. So these are all like little advanced. It will take time, but I'm just trying to show you the intent of
how these things work for the time being. Okay, so I'll again come back to this geometry, and again, if you remember last time I inserted a reference geometry, and then I can switch this to flip offset 5 mm. Yes, that's correct. And then again I go and I create insert a surface cut, and the surface I'm going to use to cut is this plane, and then I am going to cut in the top direction. That's correct. Yes, then top got knocked off, right? And then I can actually go back to the shell feature here, and I'll take this and I will say the space I want to remove, and the shell thickness is about 2 mm, right? And then you create here. So, and then again you will create some, go here, creating a fastening feature like insert, there it go, fastening feature. Yeah, and something, but this time I'll use the other one. I'll put it here and I'll put it here. Insert fastening feature, mounting boss. Something like this, and then I put it here, done. Yeah. So now the mouse will have more number of parts. You'll have a PCB board, you'll have other buttons. You have to actually start bringing all those parts and one by one, bringing everything into the, you have to make the parts and then make the assembly. That's how it is. Okay, so now you have this mouse geometry bottom. I'm just going to save this part. Now I will create a new assembly file called mouse, basically. Yeah, and I'll bring the bottom in first. Keep it here, and I will bring insert component. I'll create the top, and I'll insert it here. Oh my God, I made a mistake in this boss, so I will correct it. I go back to this. So now this is the thing. See, I realized that I made a mistake, and it has cut a hole through this boss. So I will go here, and I will go here and say open part, and it will open it there, and then which is geometry, and I make mistake. Okay. Yeah, this one. So I'm going to say edit this feature quickly. Just give me a second. Hold on. Yeah. So yeah, I switched the type. Okay. So yeah. So now if you come, go back to the, now we have corrected that hole that I had made a mistake. And now I'm going to go back, go to the window, and I'm going to go to the assembly, which I was assembling the mouse. As you can see, yes, the assembly has changed the orthodox link, should update. Now, I want to create a joint, right? So I have to mate these parts. So usually what you'll do, you'll take great care to make sure that these boss and this boss will align and it will fit into each other. So we can put a screw through this and give all those kind of things. So you'll have to add all those details. So, and then you'll have to have more, and this is not done over here, right? You'll have a cut here for the button to come out. The button will be a separate part. The inside PCBs will be a separate part, and all those things will come. And then there will be some one, sort of a stress boot over here for the wire to come out. Sorry, we are in 2021, so nobody uses not many people use a mouse with wire. But yeah, sorry. So even if there is a wire, then that comes out. So yeah, so let me just mate and then just say, let's say this surface and this surface is going to match, right? So now we can see that it has got matched together. So then maybe I can do some other mating. Usually what you can do is if the bosses are well aligned, then all you need to do is mate two bosses and it will come and everything else will sit as per the geometry. Since we don't have it, I'm going to use these external things and come over here and then come them. And then I can do another mate, which is basically say this one and that one, and see, and then sort of you can start seeing that you have a mouse right now. This is an assembly, and I'm going to save this, and I'm going to save all, and it's called MOUSE mouse. Right. So basically, you could have created the geometry in this thing, and you'd have brought it into SolidWorks. You'd have made multiple parts out of the gross geometry you got, then assembled back the geometries in a file, and all those things, and then you can actually take a rendering of it, or depending on what you want to do. So yeah. So basically, this is basically something called the assembly file, and if you had gone to the part files, what you would have seen is that you had the parts and this so-called thing called the feature tree. And if you see, this is actually basically the step-by-step every time you create you can see the history of how you went creating the part, right? And you create the cuts, and then you can take it. And there is something called the parent-child relationship. If something depends on the previous thing, then you'll have to be careful. For example, if you remove the surface, these mounting bosses will get orphaned and it won't know where to be sitting because the surface is no longer there. So you should be careful about this thing. And every time you change something at the top level, it will rebuild the entire tree. So that is the way SolidWorks works. It's basically a feature-based modeling system. So because of which it becomes very robust. The models can be very flexible. It can not flexible, but it's like it'll be very thorough. Every time you do it, it's going to be the same thing that's going to get repeated because it's like a code running and creating this geometry, and that code is is done through this feature tree. So this type of modeling makes it's not directly intuitive like how you would do with gross geometries, but once you get a hang of it, you can do it. And but this kind of modeling is required if you have to create parts that have to go out for manufacturing and things like that, right? So yeah, so that is the thing which I wanted to say. Mouse, yeah. So okay, now did I answer your question about how to create the mouse right now? Somebody had asked the question. I forgot your name.
Yes, sir.
Yeah. Yeah. Sure. Yeah. Anything else? Anything else that you wanted to ask from anybody else in the class?
Okay, so
yeah, is there anything else I have to you want me to touch upon, Kumari?
You've shown the feature tree editing of the part. You have shown that.
Yeah, I can do that. If I did, but I can just
from the files. Yeah, from the file.
From the part file. Yeah. So I can go here and go to the window. Okay, since I closed, I lost the other thing, but I'll open it again. Save and not a new file. I'm going to click open, and then I'm going to say take a plate pin assembly file. I'll open it. Yeah, so when you come here, you actually decide that you wanted to make this hole of 22 mm is too big and you want to reduce it by 2 millimeters. So what you can do is you go to the plate and then this whole of, and you can, somebody's mic is on, so if you could actually mute it. Yeah, yeah. Yeah, so I go to measure and I take this thing, it's 22, I need to reduce it by 2 millimeters. So how do I do that? I can actually take here, goes to the sketch, and then I can edit the sketch into 22. I want to make it into, so I need to make it into 20. I reduce it by 2 millimeters. Okay.
Make 10, we can see it.
Yes, correct. You're right about it. So it goes to 10. Okay, it becomes a very small hole. And now you can see it's a much smaller hole than what it was. And now if I go back to the assembly, which is the plate pin assembly thing, and so those model contained within the assembly have changed. Would you like to rebuild the assembly now? Say yes. So what has happened is that now the hole has become thing. You won't see it here because it's a lot of. But if you take a section view, if you take a section view, you can see here, as you can see. I don't know when I defined the pin to be the part diameter to be this thing. Let me just see, open part. $11.22. Okay, for some reason I'm not able to see this thing interference, but yeah, you can actually show. I'll show you the interference happening. Interference, say page length. And if you do something, surprisingly, the diameter has not changed actually. If I change, you can actually see there's, it's sort of interfering, and I can show it with something called the interference analysis and evaluate. Hold on.
Second one.
Yeah. Interference direction. Yeah. See, it's showing that there's a huge interference in this part here. Basically, this much of the material of both parts both parts have interfering, right? So I'll switch it on again. Interference detection. Calculate. It's basically telling that the part has got interference. So now to change that, you can go to the other part, which is basically window, and go to the pin part. And so you can also make it such that every time the hole diameter change, the pin dimension also changes. That needs a little more thorough modeling if you wanted to do that. But I'm just here for the example I'm doing. Since the diameter is basically 5, it's going to be 5 is going to make it 10. Right, since the diameter is 10, you need to keep the radius as 5, right? So this looks funny in terms of proportion, but yeah, that's what it is. And then I go back to the assembly, it'll again ask me the model has changed, should I update it? Yes. And now this time if I do an interference check, it'll say no. There'll be no interference at all, actually. There's no red zones. Yeah. So this is the thing. And one thing which I wanted to show you now, very interesting thing about SolidWorks is the moment you change this part's diameter here, if you go and actually open the drawings now, basically go to the plate drawing, open. Even the drawing would automatically get updated because you can see the hole has become small. So this is the thing about SolidWorks. Once you create these drawings, it is any change you create in the 3D model will automatically get updated in the drawings. So you don't need to come and manually update the drawings every time there is a change in your part. Okay, yeah, that is this what you wanted to cover?
Yeah. Was something called constraints, right? You can add conditions, right? Like
that is basically this thing called mates. Is that what you're asking to her?
No, like in a part, I want to always, even if I vary the sizes later, I want to maintain 2 mm gap between, hollow space from the other part. right? So
Yeah,
the constraint
that constraint is basically a mate. So now
that is also
I'll go back here. Imagine there is some special, you want to give always a sort of a gap between these two things. I have mated it such that it's saying it's coincident, right? This is coincident. I'm going to change this mate, edit the mate. Instead of coincident, I can actually tell the mate is going to be, let me tell you, it's going to have a distance or a parallelity thing I can give. There's a distance one. Yes, I can say distance, and it will always be say 3 mm above that thing. Okay. Now, why would that be in the mouse? I don't know, but yes, you can say. So now, if I say this, it'll always there'll be this gap always going to come. This is what you are
then,
referring to.
yes, yeah. Then
Yeah.
the rendering module, can you just show the interface?
Let me check if the installation has got this thing. But let me check the tools that is there here. Add-ons, photo view. So the rendering module is on SolidWorks is not really the best tool. Like how analysis, it's not good for analysis, it's not good for 3D view. Yeah, so now render tools have come in here. The moment you went into SolidWorks add-on and switched on photo view, there's a new tab called render tools that has come in. And you can actually, try rendering.
Preview faster.
Yeah, I started it. Let me just give you a quick thing. I am since I don't actually use this. SolidWorks Defender allow access. Yeah, so it is doing some rendering. You can actually do all the settings and things like that, and then come back and it will maybe do some rendering. But you may not find the best tool to here. Hold on 1 second. I just saw a security warning, which I want to allow SolidWorks to access that thing. Where did it go? Yeah, preview window. Clearly, SolidWorks is struggling with this thing, but yeah.
Okay, so then who can you tell the advantages of SolidWorks? I think you covered most of when we cannot use it,
Yeah.
why it is still used and relevant, if you can explain
Yeah,
about
so
it.
I don't know, with these new tools like hybrid tools like Fusion coming in, there might be changing, but as of now, this is if you want to create yeah, if you want to create parts that are like okay, so there are different tools in this category of SolidWorks. There are tools which are also just like SolidWorks, which are basically tools like CATIA, tools like Pro Engineer, which is now called Creo, and then there is something called CATIA, Creo, SolidWorks, Solid Edge. So all these tools are very similar in functionality. But then when you use SolidWorks is when the product is not too complex, but it's not, and it's like, say if you want to make a small machine, or you want to make a mouse, or you want to make a hand tool, or you want to make some, say medical device and things like that, SolidWorks is the tool to go. But if you want to build something complex, like if you're building an aircraft or if you're building an automobile or something like that, then SolidWorks is not the tool. You will go with something like CATIA or Unigraphics to for those kind of things. So similarly, you should not go to CATIA to make a mouse or to make a medical device or something like that. But yeah, but whenever the product complexity is high, you go for CATIA, Unigraphics, or it's called NX now. And whenever it is like medium complexity to low complexity, you come to SolidWorks. And if it is something simple like a flower vase or something like that, which has just it's like a geometric space, you don't even need to come to SolidWorks. You can just finish it off in Alias itself and send it off to the manufacturer with the geometry of the part. So medium to simple to medium complexity products, that is when you come to SolidWorks. Yeah.
On the CAM part, on the manufacturability also,
Yeah.
right?
So CAM, I don't know. See, SolidWorks. See, the problem with CAM is that CAM will be controlled by the manufacturing people, the people who run the machine shop or the people who run the manufacturing facility. So they will have their workflows. So they would have set it up. So they will take the geometry from you, and they may use SolidWorks, or they may use SolidCam, or they may use MasterCam. So that is typically not for us to worry too much about. So typically when you hand over the part to the manufacturing people, they'll take care of that. But if you want to operate a CNC machine and things like that, then you have SolidWorks CAM, but then it's not straightforward, because configuring the CAM and the machine, because it's highly dependent on what machine you're using, what controller you're using, and it's generally out of the skill set of a designer to be worried about that. So yeah, but SolidWorks is trying to do CAM just like how Fusion is trying to do CAM, and everybody is trying to do CAM.
Okay, so is there any questions from others? No other questions? We can wind up. I posted an assignment. So assignment would be to do an assembly modeling of a computer mouse. So take any mouse and try to reproduce it, including all the parts, and create using assembly modeling.
Yeah, I would recommend that you should actually be, if you can find an old mouse, just take it apart, and then we feel free to play around with it. And or if you don't have an old mouse, you could just buy something that cost very few cost, and then you can do that product dissection and then come back and try to model it.
Do you want to share a picture of the mouse, or we let them choose it?
Let them choose it. No, let them. Otherwise, there will be variety. I think. Otherwise, everybody ends up having to do the ugly design.
Because you don't want it to choose that flat, sleek, one surface mouse.
Yeah. You should actually choose one of the curvy models. Yeah.
So the idea is to see the part assembly tree and the parametric modeling aspect of it. So evaluation will be based on that.
Yeah.
Okay. Any questions? Can we wind up?
So I'll stop sharing my screen if everybody is done. Oh.
It's stopped.
I don't know, something happened. Yeah.
Okay, so if no questions, we'll wind up, and our next lab class will be on Wednesday. Okay, which is Fusion or Alias.
Yeah.
Yes, Rohit, you want to say something? All right. Okay. Thank you, Raghu, for coming. And
thank you.
We'll call you again for the next one.
Yeah. Thanks. Thank you. Bye.
Thank you.
Bye.
Bye.
Thank you.